Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. In today's video, we're gonna do riders. So this type of Euclidean geometry questions, we call them riders. So they are very interesting. These ones. Remember, I talked about question 10. Question 10, it is a very interesting um, question under Euclidean geometry for both grade 11s and grade 12s. But grade 12s have their own, grade 10, grade 11 rather, have their own Ulbona. So let's dive into it without wasting any further time. Now let's see. We are told that, refer to the diagram below, ST is a diameter of the second. So we have a diameter. We will never end these questions without using a diameter, because the examiner will never give you any information unnecessarily, so just for fun. Then we are told OS, it is parallel to PN. OS, it is parallel to PN. Now, if that's the case, we have the theorems, or rather the things that we can use, alternating angles. We can also use, this. This is equal to this, whichever that applies. Then we have what? We are told TO bisects. This is very important. Remember, I said know the difference between bisect and intersect. TO bisects STP. TO, where is TO? TO bisects STP. STP. So now this angle is bisected. So remember, if it is bisected, it bisects into two equal what? Two equal angles. This angle should equal to this angle there. All right. Now they told us let what? Let T1 equal to X. Let T1 equal to X. Here is that. All right. Now, first thing first, before I can move, it means T2 it is also X. Why? Because it bisects. I get TO bisected into equal angles. Now I can collect here T2 Leona, it is also equal to X bisecting. I want me to remember fella. Then another thing that I can see, we have so many bow ties here. If I can check, I have a bow tie here. If I use another color, I have a bow tie here. If I use another color, I have a bow tie where? I have a bow tie. I think this is also a bow tie. You see, there are so many bow ties here. But yeah, either way, yeah. We have also bow ties. Let me see another thing, right? If this is a diameter, an angle is subtends, it is equal to 90, but also it is a diameter, but subtends an angle there at K1. So we can also see that by doing this, also not that way like this. That this angle, if it is 90, this is also 90 again. But yes, it is subtended by the same diameter. Let's just we're gonna use, all right. Let's now 10.3.1 says now to us, prove that punk is a cyclic quadrilateral. PUNK. PUNK is a cyclic quadrilateral. Remember, I said there are three properties to prove something is a quadrilateral. Again, exterior angle of a cyclic quad. The second one, bow tie. The third one, opposite angles equal to 90. 280 rather. This is what we are trying to prove. So it's either this one will be correct, this one will, between the three, you should use one that's applicable for this case to prove the off. Now let's see. Let's try to see here. All right. Let me try this one. Let me do this. If this is my cyclic quad, or rather this is my quadrilateral, not cyclic, because we are trying to prove that it is cyclic. Now, can I prove that this and this it is equal to 180? Well, I'd prefer not to, because I think there is less information between these. So if I were to extend this here and use exterior angle, remember I said this angle here, it is 90 degrees. That angle there. Remember I said this angle here, it is 90 degrees. I also said this angle here, it is 90 degrees. So remember, if I want to use exterior angle, it means I'll have to say this angle, it is equal to the interior. It is opposite to which angle? To this angle. So if I can prove with this angle also, this angle here, K2, K3, it is equal to 90. If I can prove that this is 90, then it will be a cyclic quad, because exterior angle of a cyclic quad equal to the interior opposite angle. But now, if I see here, this is also 90. And if that's also 90, if I use angles on a straight line like this will be 90. So if that's 90, it means it will be a cyclic quad. Now, I think there is somewhere where I'm going. I'll start here. I'll start by saying now, angle U1, it is equal to 90 degrees. Angle in the semicircle, this is 10.3.1. Angle in the semicircle, okay? Then I also have K1. This is 90. K1, angle K1, it is also 90 degrees. Y angle in the semicircle. Or you can use this reason. Or since well you now see this is a bow tie, kind of like this and this again. One might prefer using this one, saying angles in the same segment. Either way, it's the same, whichever that you saw first. Then, now I said this if it is equal to 90, and I know this is a straight line, and this is 90 degrees. It means this angle here should also equal to 90. And that is the angle that you are looking for. We can say, and now PKN, let me, PKN like this, PKN, this angle here, it is also 90. Why? P angle KN, it is also equal to 90. Why are we saying that? Adjacent supplementary angles. Supplementary angles, or angles in a straight line. Again, now, if this is equal to 90, and this is equal to 90, and this that I'm looking at here, it is a quadrilateral. Then do you all agree what I'm seeing here? I'm seeing more or less something like this. From the theorems that we've done, something more or less like this, where I'm saying this angle should equal to the opposite interior. You understand? So it means now this angle, this if it is 90, also that one it is 90. So this is what the theorem, that's theorem 6, that says the exterior angle of a triangle is equal to the opposite interior. All right. So yes, I think if we have done this, we can now say, therefore, angle U1, it is equal to angle PKN, it is equal to 90 degrees. Again, proving. Therefore, you can conclude by saying, therefore, Planck is a cyclic quad. You should give a reason why you are saying punk is a cyclic quad. In this case, you are going to say, when you are trying to prove something, or it is a quadrilateral, or it is a tangent, it is a what, you're going to say converse. Converse is a reverse. Converse what? Exterior angle of a triangle. Of a cyclic quad. Now, here I'm saying U1 it is equal to PKN. Why? Because of converse exterior of a cyclic quad. Yes, the reason is exterior angle of a cyclic quad, but in this case, remember we had to prove that it is a cyclic quad first, so hence we are including what? Converse. I believe you are following. If you are not, please try to go back to the video again. Go back to the video. I want to say, go back and watch again before continuing with this video. So we have proven that we have a cyclic quad there. I can remove this. I can remove this. I can remove this so that you can have more space to prove other things. To prove other things. Now let's just fill out what we know. This is 90. This is 90. This is 90. Yeah, that's all that we know. And we know that what we have here, we have a cyclic quad. All right. Now let's look at a 10.3.2. SO is a tangent to circle. SO is a tangent to circle KUST. So to this circle, all right, it's fine. Now, I think the proof that I think they left proof that they, all right, they normally do that like this. Proof that that is a cyclic quad, so is this, so that they can avoid saying proof now and then, because now they have forgotten. All right, it's fine. We are required to prove that SO is a tangent to circle, this circle. Now, where is that SO that they are talking about? SO. Here it is. So if SO is a tangent, I know the property that I can use is that this angle here should equal what? That angle. If I can prove, normally what I like to do is, I like to say what they are trying to say is that prove that, required to prove that angle S1 it is equal to angle T1. If you can prove that angle S1 is equal to angle angle S1 it is equal to angle T1, then you can conclude by saying therefore OS it is a tangent to a circle. As long as they haven't told you that, you cannot conclude that. Now let's see how can we prove that. This angle here and this angle are equal. We are trying to prove that. Now let's see. The first thing first that I can see is that I know that T2 it is equal to X. T2 it is equal to X. Let me do it here. 10.3.2. T2 it is equal to X. Why am I saying that? Remember TO bisect what? Bisect, where is that? TO bisect STP. I get. Then another thing that I can see, I want to reach here. Let me see which angle I can use to reach there. I'm trying to look closely. All right, let me remove this. All right, if I look at this, I can see that T1 it is equal to angle K2. We agree? T1 it is equal to angle K2. Now, one might ask, oh, why am I talking about K2 now? Because K2 correlates with P1. I'll show you. I'll show you. I'm trying to find the relationship so that I can find it, get to the last part. Now, I'm going to say another part, T1. Can you please include angle? Angle T1 it is equal to angle K2. Why am I saying that? Please indicate that is equal to x. Why am I saying that angles in the same segment? Angles in the same segment. Now, all right, this is also equal to x. But I can also see the bow tie, another bow tie. That includes K2 again. This one. So we agree that this angle it is equal to P1 there. Sorry, angle K2 it is equal to angle P1. It is equal to x. Why am I saying that angle in the same segment again? All right. All right. Now that I see that P1 it is equal to x. Let's see something. All right. Here is P1. P1 okay. But check something. As I go down with this line, I can also find this thing. Again. Now, we agree with if these two lines are parallel, the angles are alternating. These angles, angle P1 as well as angle S1. Yes. So therefore, I can use that and say angle P1 it is equal to angle S1. It is equal to x. Why am I saying that? Remember, what's the reason, Hannah? Alternating angles. But you should say such that OS it is parallel to PN. How? But now, Joe, if this S1 it is equal to x and T1, I think and T1 it is equal to x, then it means this is what I was trying to prove. And remember, the main focus was to prove that S1 is equal to T1. And now I have found that S1 here, it is equal to T1 there. So it means now, if that's the case, it means this theorem A that says if I have a tangent here, then I have a chord, maybe a chord here. The theorem that says this angle here, it is equal to what? I'm gonna say this is my tangent, this is my chord. The angle between a tangent and a chord, here it is again. Then I'm gonna take my chord. The chord that I'm talking about, it is this chord AB. This chord, which angle does this chord subtend? This chord subtends an angle there, so it means it will equal to that angle. If this is x, this is x. This is what we were shown here. Hooray. All right, if this is my tangent, and with this chord US, so let's see which angle does US subtends. US goes there, U goes there, I mean to T, as well as T goes there, S goes there to T. So it means what? This angle is X and this angle is X. And we have proven that angle S1 it is equal to angle T1. You can say therefore angle S1 it is equal to angle T1 it is equal to X. That one we have proven. Therefore, if these are equal, therefore S1, therefore what's OS or SO? OS is a tangent. If these two are equal, it means it is a tangent. But remember the reasoning. The reasoning should be what? It is converse. Because remember, it is the reverse. Converse of what? Converse of what does this theorem say? If the angle between a tangent and a chord is equal to the angle in the alternate segment of the circle, we are saying converse tan chord theorem. Tan chord theorem. So if this angle is x and this angle is x, therefore the reason it is what? Tan chord theorem, because it is an angle between a tangent and a chord, as well as the angle subtended by that chord. So for theorem 9, we use tan chord theorem. So I believe you are following. I strongly believe you are following. Even though you are not, I know it's difficult. Try to watch this as much as possible and try to do as many questions as you possibly can if you want to master question 10. Question 10 is a struggle for many students, and they like to say it is a question that's mostly done by maybe top students, but never let that sink into your mind. Never have that mentality that questions such as question 10 are only done by those that are more smarter. All right, it all takes hard work. Lena, I used to struggle. I found the answers, but with a lot of struggle when it came to question 10. Also in my grade 12, I struggled to find the proportionality to what, but at the end I managed to, because it all wants hard work and practice. All right. Now the last one, prove that P, where is P? I cannot locate P. Here is P O S T S S T, something like this. Now we are told to prove that it is a cyclic quadrilateral. If I see there, if I can see here, I can have this, this, this. I'm done. I'm done. I'm done. I am done. Because why? Because now, if this is my cyclic quad, if I'm trying to prove, if I can prove that S1 it is equal to angle T2, then I'm done. Again, and remember, if I'm doing this, this is very straightforward. I'm going to say angle T2 it is equal to angle T1 it is equal to X. This one we have already proven it. Again, in the last question, where we said the reason it is what it is, actually what they are trying to say to me, required to prove that angle T2 it is equal to angle S1. This is what I'm trying to, I'm required to prove. If I can prove this T2 it is equal to S1, then it is a cyclic quad. Okay, therefore T2, I have now T2. Now let me find anything related to S2. But remember, we also said S1 it is equal to T1. We said angle S1 it is equal to angle T1. That one we have proven, Leon. We also proven that when we said it is a converse of tan chord theorem again. Therefore, if I have proven this, therefore, can you see that? Aman. Can you see that T2 it is equal to X and S1 it is equal to X, and they are both equal to S1. So if that's the case, therefore, I can say therefore angle S1 it is equal to angle T22. It is equal to X. Again, then if that's the case, therefore, if that's the case, I'll continue here. Therefore, post is a cyclic quad. Why I'm gonna say that? We used what here? We use a bow tie, so I'm gonna say converse, not converse bow tie. Converse angles in the same segment. So yeah, that's all for this question, folks. I hope you managed to catch one or two things. Try to practice these questions as many times. Practice, 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 practice. If you want to master question 10, you have to practice, practice. You're gonna struggle, 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 but at the end, you will finally get it. All right. But to question 8 to question 9, make sure that these ones you can do, because the level of difficulty increases as you are completing the question paper. Question 8, remember, it is proving. Remember, I won't do proving because it is I have already done them under Euclidean geometry theorems. So thank you very much, folks, for watching my video. Until we meet again on the next video, thank you very much.